about Lewis structure. When we talk about Lewis structure includes the bonding and non-bonding electrons, right? If you remember, this is our water molecule. H2O is written as a Lewis structure like this. In this case, whichever bonds are shared electrons, they make a bond, right? And these are called bonding electron pairs. Bonding electron pairs, right? These two are bonding electron. And when you see lone pair, like a free electrons, not used for making a bond, so these are called, what do you think? They are bonding. So if you have a free electron, it is called non-bonding or lone pair. Non-bonding electron pair or lone pairs. Okay, so whenever you have Lewis structure, we always gonna show you might have some Lewis structure, no lone pair at all. Some you're gonna have bonding as well as lone pair, right? And each bond equal to 2 electrons. Make sense? So in this water molecule, you have, if I ask how many bonding and how many lone pairs, you're gonna say 2 bonding pairs and 2 lone pairs. Make sense? So this is for the water molecule, right? So this is considered Lewis structure. Now you can draw Lewis structure for anything, provided you know these rules. Okay, I'm not gonna erase it until we all finish. So make sure to listen carefully that how we gonna draw, and I'm gonna explain by one step wise. Okay. Do we have eraser? Yes. So you got it right. In water molecule, this is the Lewis structure. And once I show you a couple of examples, you will know how to draw Lewis structure. And I picked the difficult ones from your list. And also, if you remember, I told you I'm gonna make this as your one of the lab quiz. You see, like you don't have to take other lab quiz, so you can just upload this as a lab quiz. But it's not gonna do until next week. I want you to focus tomorrow, and after we finish lab here, I'm ready to help you with the exam questions in our room, okay? All right, so let me show you now with the rules, one at a time, and I wish nobody missed class today. So this is very important and one very important topic in chemistry. Like if you know how to draw, then you will feel very good that, oh, that's how the Lewis structure are, right? Now, whenever you are drawing Lewis structure, the first thing you have to do is count total valence electrons. So what do you mean by valence electron first, right? Since you haven't heard that too. So the valence electrons are outermost electrons. Outermost means in any atom, right? You might, like if I say how many valence electron in hydrogen? Hydrogen is just 1 electron, so there's just 1, right? Like if I say how many valence electron in sodium now, see, this is actually, we haven't learned that electron configuration yet. So sodium has 11 total, but the outermost will be, like, see, you will have nucleus, and then I'll talk about in chapter. So 2 electrons will be in the first energy level, second is 8, and the last one remains on the 1 is the third one, right? So the outermost is how many? 1. So that's why you really need to find out how much is the valence electron in each and every element. Since we haven't learned the electron distribution yet, I'm going to give you the very easy way to find your valence electrons. So make sure you take that note, okay? But anyway, you understood valence electron means the outermost, okay? And then similarly, if you have, let's say, magnesium, or magnesium is 12, right? So magnesium, it will be like a 2, 8, and 2 in the last one. So valence electron is your 2. Likewise, and if I say chlorine, right? Let me give you one more final example. Chlorine has 17 electrons. You will have 2, 8, and last shell will have 7. So that means your valence electron for chlorine is 7. Clear? Now, as I said, since we haven't learned the distribution of electrons yet, So there is a very nice way to remember how many valence electron. So that is with the help of group numbers. So you remember group, you have how many groups? Group 1 to 18, right? And now the valence electrons are equal to group number. So that way now you know very easily how many valence electron for first group, then you can say 1, right? So group 1 means 1 valence electron. If you have group 2, this is your 2 valence electron and so on. But what about when you have group 11, 12, 13, 14 then? So let's say group 13, 14, 15, like that. So ignore the number 1 front. The second number is going to be your valence electron. So if I say how many valence electron in group 15, you're going to say 5. How many group 18? 8. Makes sense? See? You don't have to know distribution yet. So it's the easiest way. You can just look at your periodic table and you're going to look for your valence electron. Clear? Now here, so everybody understood what is valence electron, right? So once you have it, now you're going to try how to do. Now I'm going to give, this is one of your problem that you have to do in the page, right? So the COCl2. So first thing is to count the total valence electron. Now look where is carbon is. So the total valence electron we are trying to find. Carbon is in group 14. That means 4 valence electron. Very nice. See how easy. Oxygen is in group 16. So valence electron is 6 plus chlorine now. It is in group 17. So that means it has 7, right? But see how many chlorine we have though. So you're going to do like this. 2 times 7. So don't forget to, whatever number there, you have to be very careful. So this is how you calculate your total valence electron. So calculate it, how much total? 10 plus, it is equal 24 valence electron. Everybody good?
Wait, yes.
Yes, Lydia.
So you took 4 plus
4 for the carbon plus 6 is for oxygen valence electron plus whatever element there, you have to add them though. And chlorine, you have 2 chlorine there. So that's why 2 times 7. Each chlorine valence electron is 7 because it's in the group 17. Make sense?
so you have to time.
You have to, this is times of course 2 times 7 and then rest you just all gonna add. So total 24. Good? So this is how your first step to do in your problem is total valence electron. They ask you, see, total number of valence electrons. So this is how you calculate your valence electron. Now once you have this, what's the second rule now? Look, select a central atom and give 1 bond to each peripheral. Now in any compound, you will have 1 should be central and the rest is going to be your peripheral atoms. So how to determine central atom? It depends on the least electronegative. Now we haven't learned this also. See, it is sometimes really hard to, but anyway, you can at least get electronegativity means the ability of an atom to attract electron towards itself. Electronegativity means they love electron, right? So as you go from, so for the time being, just remember your electronegativity increases as you go from left to right. Means in a periodic table, right? When you move from left side to right side, your electronegativity increases. So that means most of the metal is left side, remember? So those gonna have less electronegativity than right side one. So more left, less electronegative. So based on that, when you see this thing, you have to decide according to where is this. See, carbon is group 14, oxygen 16, this is 17. From that rule, carbon comes the 14, and then oxygen, chlorine. So which one will have low electronegativity? Carbon. Makes sense? So as I say, also one tips, whenever you have any compound and you are trying to do the low structure, if you see carbon element there, You don't have to think anything. Make carbon as central atom. That's the tips for anytime you see carbon compound, any species, carbon takes always the center. Okay? And by rule also, this is the least one compared to this, right? Alright, so we have central atom carbon. So it's number 2, okay? We choose a central atom and now give one bond to each peripheral atom. So after I take one carbon, what are your peripheral atom? You have oxygen and 2 chlorine will be your peripheral, right? So I'm just gonna give one chlorine here. You can put top also, not a big deal. And what else we still have? Oxygen. One bond to each we said, right? So once you have it, are we done? Also keep track of your electron, okay? So see number 2, I'm just done up to number 2. First, we counted total valence electron, which we found 24. And then second, we selected a central atom and we give one bond to each peripheral. And keep track of your electron. Each bond equivalent, how many electron I said? 2, right? So total how much we use? 6. So I want you to just keep track. No need to show, but in the beginning it's always wise to do the keep track of your electron. We still have 18 electron left, right? 24 minus 6 is 18 left. Makes sense? We just give 2, 4, 6 electron now. So we done second step. So far so good. I'll give you another example to don't panic. And number 3, what it says, look, make octet to all peripheral atoms. That means peripheral atoms except hydrogen and helium. So make all the other peripheral atoms. Octet means to cover with 8 electrons or to have 8 electrons, because that's the state they become very stable. Except hydrogen helium, because hydrogen helium they're happy with 2 electrons. So that also shows you whenever you have hydrogen never gonna be central. Makes sense? Because it is okay with just 2. So central atom should be something that can bear minimum 8, and some are exceptional, there are more than 8 also. Okay, so far so good. Right now, according to step rule number 3, we're going to make octet. Means since 2 already there, how many this need now? 6 electrons, right? So how I'm gonna add? When you add free electrons, try to pair up. Try to put it like a 2 together, okay? So chlorine now, very good, see, with 2, 4, 6, 8, right? Likewise, this chlorine also need 6 because it has 2 already, so this is good. What about oxygen? This is 2 already there. How many this need? That also need. You want to make 8. 2 already there means you still need 6 of them. So 1, 2, 3, 4, 5, 6. Looks so good. See, they all happy, these peripheral now, right? And then I just used up how many? Total 18 I just used, right? Just giving this lone pair. Can you see from here? So giving this, we have all used up. Are we done this?
Why you did take away 18? Why you did that?
No, because we just distributed 6 times 3, right? 6, 6, 6. We just used this 6 lone pair we gave, and we just used up. We just used up all of them. Now, is it good? Are we done?
So when you say it has 2 already?
This one bond equal 2 electron. So
Okay.
it has 2 already, so need 6 more to make 8. Got
The
it?
problem is how we get 2 oxygen. That part skipped.
What 2? There is no 2 oxygen. We have only 1.
Yes. So
Right.
But you said it's 2 there.
No, this one bond equal 2 electron. Because this is bonded with carbon already. So 2 electrons are already with that oxygen. So it just needs 6 more to become total 8. Right? So here, but now we have no more electron left, and what we need to look when we are making Lowestar, each and every element should have 8 electrons. That's the target we should keep. Do you think everyone has 8 now?
No.
Which one does not have?
Carbon.
Yeah, if you look at this chlorine, you have 1 bond and 3 non-bonding, right? That makes total of 8. You can make like this, say make a circle. So how many? 2, 4, 6, 8. Because each bond equivalent 2, we said, right? So, wait. So we did looking at the peripheral atoms, each and every one is 8 electrons. But now carbon only have how many? 2, 4, 6. This bond means this carbon also attached to that bond, right? These bonds are formed by sharing. These are free electrons, not used for bond yet. So looking at that, carbon still need 2 more electrons to become 8. So if you look at rule number 4, what it says, make central atom octet. We don't have any electron left, right? If run out of electron, make double and triple bond. Remember? So in this case, do you think this chlorine can make double bond? If you remember, what's the charge on chlorine? If you remember, -1, right? So double bond is barely possible with chlorine. -1 means they are happy with 1 electron to get, not like a 2. If you remember, oxygen -2. So that means this oxygen is very happy to share. It's that lone pair. So since one bond equal to 2 electrons, right? So this one of the pair can be make double bond here. So that's why I'm just gonna erase this and make a double bond here. You see? Now this is shared now, right? This bond means sharing. That's why if you count, let me make a circle. See, this is total 8. As I said, low structure, mainly we're looking for making 8 electrons, right? So this is 2, 4, 6, 8. 2, 4, 6, 8. Now oxygen also 2, 4, 6, 8. Looks very good. And what else? This carbon is good too, right? 2, 4, 6, 8. So this is what we are looking for, and this is the very best picture for carbon COCl2. Yeah?
I have a question.
Yes.
So why you didn't use chlorine?
Because chlorine normally has only Cl minus. It's only 1 minus charge. If you give double bond there, chlorine not gonna have double bond. -1 means they just want 1 electron, right? So that's why instead of chlorine, but oxygen, if you remember, is a -2. So oxygen is very happy to have double bond. That means sharing 2 electrons, so they will have -2 on the oxygen.
So whatever atom has the more.
Whatever they have the charge, yeah. So oxygen not willing to make triple bond. It won't be stable. So if it is double bond, that's the stable for it. So triple bond possible is with nitrogen. If you remember, nitrogen is group 15 with -3. Got it?
Yeah.
So far? Yeah, I'll give you another example too. So just hold on.